Start that. All right. Okay. Oops, not this one. Okay. Can you see my screen? Can you see my screen, guys?
Yes.
Yes. Okay. Now. Okay. All right. Now. Okay. Today, what we're going to do is we're gonna study. We're in week 9. For your information. We're in week 9. So for today's class, you need to. Don't forget, you need to fill up in the attendance. Okay. So we're in. Oh, sorry. We're in week 9. To be exact. Okay. We're in week 9. What we're going to do is we're going to study the equation of motion of rigid body, but we're going to use Newton's second law. Okay, so equation of motion of rigid body. We know that rigid body is the difference is for rigid body it has rotation. Okay, translation pun ada, rotation pun ada. But before this, previously, when we studied particles, it's more of translation only. Okay, but now when we're dealing with rigid body, there is a rotation occurring. Okay, now, so equation of rigid body, if you're using Newton's second law, it will be this first formula, this one lah. So this one uses Newton's second law lah. Okay, Newton's second law. And to law. I just a short form, okay? So Newton's second law, F equals to ma. What does Newton's second law is? It relates to the resultant of external force and the acceleration. So when you have a question that is rigid body that is related to Newton's second law, what you're going to consider is all the external forces and the acceleration. Okay, but of the mass center G of particles. So maksudnya kita akan take into consideration at center of gravity G because it's a rigid body. Okay, all right. So this is for apa? If you use Newton's second law. Okay, the other thing is also we can what we can do is we can also take moment. When we take moment, is take moment and also a center of gravity G. It relates to the moment resultant and angular momentum of the system. Okay, but for this topic, we will not learn today. The second topic, we're going to learn maybe this Wednesday. Okay, but today we're going to focus our question on rigid body that uses Newton's second law. Okay, all right. So basically, for questions that are related to rigid body Newton's second law, it's very similar. Our course outcome is we basically sometimes they ask you to determine the reaction, the friction. They ask you to determine the acceleration. They ask you to determine the force. They ask you to determine the angular acceleration. It depends, okay, on the question, what they ask you to do, okay. But today we're gonna do this question, okay. So yeah, as long as you understand, for rigid body, you uses Newton's second law is F equals to ma. You can solve any problem, okay. Okay, sebenarnya dynamic ni is actually very easy, okay. So don't have to worry. Okay, but maybe your what you call that, your assignment is a bit difficult because your assignment you are given more than a week to prepare. So sometimes we make it slightly difficult because you're given almost 2 weeks to do it. Okay, so we expect you can perform very well. So maybe the question is slightly hard. But I see many of you have submitted. Many of you have submitted your assignment. Ada tak yang masih belum submit? Semua dah submit dah? Semua dah submit assignment? Syafiqah Syarim dah submit? Belum. Muhammad
Ya.
Ali Firdaus belum submit. Okay, okay. Dah, okay, alright. Okay, so I guess some of you are very happy because you are given an extension until the 16th. Okay, maybe some of your wish came true lah. Okay, siapa yang memohon supaya test tu di extend Okay, alright. But we had a problem with the uploading, but it's now fixed. So those that can now submit in Evans. Okay, now can you? Oh, have you finished copying what I wrote up here tadi? Ni, have you finished copying this? Azim, have you finished copying this?
Belum lagi, madam.
Ha, kenapa senyap ya? Apa risau pasal test malam ni ke? Jangan risau. Okey, senang. Boleh jawab dalam sejam. Okey, apa yang saya ajar, example saya bagi, it should be fine. Okey. Okey. Azim dah habis kopi bagi tahu?
Okay.
Sementara you salin, saya nak pesan ya. Saya diminta untuk menghantar attendance kalau siapa yang tak comply 80% attendance, nama akan diberi ya. I hope you all are filling the Evans attendance form. Okay. Jangan ada pula yang tak buat ya. Okay, any of you, kalau you rasa you ada problem dengan subjek dynamic ni, why don't you contact me personally and let me know of your problem. Okay, jangan jadi hero I'm always here maybe hari Khamis, Jumaat, I'm always free So you can contact me and we can discuss. Okay, Azim dah habis salin dah?
Dah.
Azim, dah?
Ha.
Okay. Okay, now kita nak buat soalan ni Okay, this question. Okay, can you please copy this question? Okay. So this question is a topic of rigid body. Maybe at first when you look at this question, you think, oh, this is Newton's second law particles. No, it's not. It's rigid body because the wheels are rotating. Okay, it mentioned the wheels are rotating. Okay, when the wheels are rotating, and then they ask you to find the normal reaction of the wheel that is rotating, it means this topic is rigid body. Okay? Alright. And then when you observe this question involves moving in a translation form, it means is moving in a straight line, you can use Newton's second law to solve this problem. So this question is rigid body. So we take note. This is rigid body. And this is, we're going to use Newton's second law lah to solve this problem. Okay. Alright. Okay. Okay, siapa yang nervous untuk test malam ni, jangan rasa nervous You should be fine, okay? You're gonna be fine. Okay, don't worry Tak nampak muka you all, saya tak tahu muka you all ni muka senyum ke, asam ke, sedih ke. Itulah. Tak apa. Saya faham. Kadang-kadang bila kita on camera, internet tak berapa bagus kan. Dia boleh stop kan. Jadi saya tak paksa you buka kamera lah untuk hari ni Tapi mungkin kita punya, at least kita punya last day class, boleh kalau tak? Boleh tak saya minta buka kamera untuk simpan kenangan? Boleh? Boleh tak Azim? Hmm?
Boleh tak tu?
Hmm. Kenapa saya asyik panggil nama you?
Saya pun tak tahu.
Nama anak saya Azim? Nama anak saya pun Azim. Dah? Okay. Alright. Okay, so kita tengok this question we do it together Okay, now when the forward speed of the truck shown was 10 meter per second, okay, what do you understand bila dia kata the forward speed of the truck was 10 meter per second? So what do you think 10 meter per second means? Huh? What does 10 meter per second means? Dia punya speed kan? So dia punya V0 So dia bergerak ke kanan dengan V0 berapa? 10 meter per second. Okay, the brakes were suddenly applied. So bila ada brake applied, apa jadi? You macam ada ghostan ke belakang sikit, betul tak? Pernah bawa kereta tak? Ada kan? Bila you suddenly apply a brake, you akan decelerate. Instead of accelerating forward, kemungkinan you akan decelerate ke belakang sedikit. So, causing all four wheels to stop rotating. So, asalnya dia tengah rotating bergerak dalam bentuk translation. Lepas tu, apa yang berlaku? A brakes was applied, so it stopped rotating. Okay, so it was observed that the truck skid. So dia skid and to rest in 7 meters. Maksudnya the truck was moving until it reached 7 meters. So when it reached 7 meter, they stop. Okay, now the question is determine the magnitude of the normal reaction. So dia nak N. So normal reaction tu adalah N. Okay. N of the friction force. Friction force, apa simbol friction force? Mu K. At each wheel as the truck skid to rest. Okay, so dia skid to rest. Apa maksud skid to rest? Apa jadi dekat V, velocity dia at the end? Kalau V0 adalah 10 meter per second, dia skid to rest, apa jadi V?
Zero.
Yes, zero. Okay, please I need one or two of you to respond to my inquiries to my message Okay, now the weight of the truck is Wn, maksudnya W Newton. Okay, now dekat sini dia kata weight. Where will the weight be? The weight will be vertical pointing downwards, right? But where? At what position? Where will the weight be? Nak kena
Point
panggil
G.
nama. Yes, at point G. Okay, for this question, dia bagi tahu whatever the weight, it must be at the center. So sometimes I've noticed when you do your assignment or do your test, exam ke apa, sometimes the way you draw the weight is wrong. It must always be at the center. So bila you nak buat point the weight pointing downwards, tolong lukis betul-betul dekat center of the object. Okay? Alright. So the weight is here. Pointing downwards, it's W. Okay, now. So to complete this question, we need to draw the free body diagram. I advise for you when you do your dynamics test, free body diagram you must draw. Okay, completely draw. Jangan tinggal-tinggal. You akan dapat markah. You tak lukis free body diagram, you tak label dia punya length, dia punya apa? Whatever free body diagram, dia punya weight, dia punya friction force, dia punya normal force, whatever is in the free body diagram, if you tak draw, you will lose marks. of course you nak yang markah penuh. Am I right? So make sure you draw the free body diagram and jangan draw cincai-cincai. Okay? Alright, because sometimes if you draw a wrong free body diagram, your equation will be wrong and you cannot solve. Okay? Alright, so the weight will be at the center. Okay, now, alright, the weight will be at the center. Okay, and then they ask us to find the normal force for each wheel. Okay, so let's say correct. Let's say we have what we have two wheels. Satu wheel A. So this will be our normal force for wheel A. And then we have wheel B and B. And here it mentioned that the wheel has friction force. So if the car is moving to the right, the friction force will be the opposite direction. So this one will be the friction force for B, and this direction will be the friction force for A. Okay. The other diagram that we are missing is the kinetic diagram, so we need to draw that diagram. Okay. Okay, so you need to draw again the car. Sorry, it's not a car, it's a truck. Okay, all right. And then here we have M A. All right. Okay. All right. Okay, now let's solve this problem. Okay, macam mana kita nak dapatkan kita punya NA dengan NB ni? Macam mana kita nak dapatkan NA, NB dan macam mana kita nak dapatkan friction force? Now, kita tahu friction force F is mu Kn. So this is something that we need to find, the friction force, and we also need to find find the friction force for Fa. We need to find the friction force for Fb, and we need also to find we need also to find what is Na and what is Nb. Okay, so this is what we need to find. No? So how are we going to do this? Does anyone have a suggestion how to start? Because sometimes in the test or assignment or exam, what I am worried is how you start. Okay, how are you going to start to do this? I need your ideas. Okay, what equation that you have in mind yang ada all these parameters? What equation that you have in mind that has all these parameters? Hmm?
Scalar equation.
You mean the summation forces Fy, Fx?
Summation.
So,
Yes.
yes, betul. So let's write down that one. Okay, first to see what we need. Okay, so for here, you will be summation forces Fy will equals to summation forces Fy effective. Okay, this is something that you need to write. Even this equation, this equation, you will get 1 marks. Okay, so summation forces Fy equals to summation forces Fy effective. So from this equation, can we write the equation together? What do we have? We have Na plus Nb. What else? What else you have from here? What else you have?
W.
Okay, minus W equals to 0. Okay, so you understand you have this equation. Okay, but from this equation, how are you going to find Na and Nb? You still cannot find it yet, right? So we have another equation that is summation forces Fx. So let's write down that one. Summation forces Fx equals to the summation forces of Fx effective. Okay. So summation forces Fx, what do you have? Okay, wait. Summation forces Fy, we're assuming top to be positive, and summation forces Fx, we're assuming this direction to be positive. Okay, all right. Now, summation forces Fx, what do you have? You have FB, you have FA, and you also have MA. Am I right? We're looking at this diagram. What do you have? So, what is our FA and FB? Would it be positive or negative?
Negative.
Negative.
Yes, it will be negative. Okay, but how about our MA? Now, do you know the direction of your acceleration now, right now? Do you know that is your acceleration, is it moving to the left hand side or is it moving to the right hand side? Do you know? Can you find out? Okay, let's find out. You need to find out because the direction of the acceleration determines whether the direction that you are assuming earlier is correct or not. Okay, it depends on the question. Okay, you cannot assume always the direction is positive. Okay, so let's see. Okay, what do we have? We have V naught to be 10 meter per second. We have V to be 0 because it comes to a stop. And then what do you have? You have S. What is S?
7
What is
meter.
your... Yes, 7 meters. Do you think you can find A? What formula of the kinematic basic equation that you can use? You remember the kinematic equation? What equation you can use? Let's look
Uh,
back at the basic kinematic equation. You remember? You have a number of equations, right? That
Formula
you
number
can use
3.
to find the acceleration. I want you to find the acceleration. Let's write down the equation, because mungkin some of you don't remember. Okay, this is the first equation. Second, okay, I hope you are with me, Jangan ada pula yang first time pula tengok formula ni, The basic kinematic equation. Okay, so which formula you can use to find A? Which one? You want to use the first, a second, or third? What do you think?
Nombor 3.
Yes, number 3. So if you look at the third equation, so V squared is 0, V naught is 10, A we need to find, and S minus S naught, it means 7 minus 0 is 7 lah. Okay, so what is our A? Can you find me what is A? Do you have a calculator? So what is your A? Hello? Hello? What is your A? 10 kuasa 2
0.7.
Hah? Are you sure? Kira lagi sekali? Ni buat saya pula nak tekan calculator. What is your A? Cepat. Zero tu salah.
Negative 7.41.
Negative 7.14 unit meter per second squared. Okay, so what can you see here? What happened to your acceleration? Dia decelerate kan? Because the car was moving at a speed of 10 meters per second and then all of a sudden dia applied the brakes. So what happened to the acceleration? Dia decelerate. Dia decelerate berapa? Negative 7.14 meter per second squared. So from there, you know that your acceleration is actually moving that way. Okay, your acceleration. Okay, so now if you want to write the equation for your summation forces of fx, it will be okay negative. You can put in negative fa plus fb because it's in that direction negative equals to negative ma. Okay, all right, all right. Okay, now so you have this, you have fa, fb, ma. All right, you have a. So how are we going to solve this problem? So if you notice FA, what is the equation for FA? Is mu Kn. Am I right?
Yes.
And what is mu Kn? Mu Kn is equals to mu Kmg, right? Because normal force is the same as the weight. Okay? Do you get that? Are you with me? Okay? So FA, what we can assume is, wait, let me write the assumption here. Okay, here for your understanding, FA plus FB is also actually equals to mu K NA plus NB. Okay, and then mu K is NA plus NB is actually equals to what? The weight. Am I right? You understand that? NA plus NB is actually the weight. Okay, so it's actually mu KW. And what is mu KW? Mu K. What is W? Is actually mg. So basically, negative FA plus FB is actually negative mu K mg equals to negative m. And then what is the A that you get? Negative again, 7.14. Okay, so from there you can get mu k. So what is your answer for mu k? So it will be negative m minus 7.14 divided by negative mg. So you can get mu k. So what is your mu k? Ni setuju tak? Na plus NB ialah weight. Sama kan? That one kita dah tahu kan? Dari mana datang Na plus NB adalah weight? Datang dari sini kan? Betul tak? Formula ni kan? Weight akan equals to Na plus NB. Ni. Nampak tak formula ni? Ni. I lukis kotak ni. Okay? Alright guys. Your weight is equals to Na plus NB. That's why mu K W. And then everybody knows weight is equals to mg. Okay, ada tak you all lost? Okay tak? Boleh terima tak? I'm going very slow Okay, what is 7.14 divided by gravity? What do you get? What is your mu K? 0.728. Okay, so that is your mu K. So you dah dapat mu K. Okay, now what is the next step? We need to find NB atau NA, betul tak? Mu K dah ada. So we need to find NA dengan NB. Okay, now. So, formula ni you dah biasa pakai ya. Formula apa tu? What do you call that? Summation forces Fx, summation forces Fy. There is one more formula, summation forces moment. Okay, because you nak dapatkan NA dengan NB, maksudnya you need to matikan salah satu, NA atau NB. So kalau you nak matikan NA atau NB, okay, ni you belajar masa you taking moment about a point. Kalau you take moment dekat point, okay, you cuba bayangkan, you take moment about point A, you akan ada apa? When you take moment, moment adalah force multiply distance kan? So when you take moment dekat point A, dekat dalam gambar ni, truck ni, you take moment kat A, W kali panjang dia apa? 1.5. NB kali panjang dia berapa? 2.1 campur 1.5. FB, you boleh kali tak panjang? Tak boleh. Sebab moment adalah force multiply perpendicular distance. Kalau you take moment dekat NA, FB ni tak boleh pakai. Yang hanya ada adalah apa? W dengan NB. Boleh tak guys? Faham tak? Nak kena panggil ni, you all ni. Siapa? Nur Shazrin. Nur Shazrin? Afza? Nur Shazrin? Afza? Hello? Nur Shazrin?
Boleh Doktor?
You faham tak when you take moment kat A? Okay, apa you faham? Moment adalah force multiply distance kan? Betul tak? Shazrin? Hello Shazrin?
Ya Doktor.
Moment adalah apa? Moment adalah apa? Force multiply by distance. Distance tu mesti perpendicular distance. Okay, so bayangkan you take moment dekat point A, dekat tayar A ni. Apa forces yang tinggal? Weight, betul tak?
Wait.
Weight. Apa perpendicular distance weight tu?
NA.
No. Weight tu, apa dia punya distance dekat point A tu? Perpendicular distance dia. Berapa value distance dia?
15 meter tu ke?
1.5 meter. 15. Okay, good. Okay, so when you take moment dekat wheel A, the weight is going to be multiplied dengan perpendicular distance, which is 1.5. Betul. Lagi satu, NB. NB, berapa dia punya perpendicular distance dekat point A? NB ni, berapa dia punya perpendicular distance, Shazrin?
Yang 1/5 tambah 2.1 tu ke Doktor?
Yes, betul. Okay, good. Now, FB ni, friction force FB ni, ada perpendicular distance tak? Dekat point A. Ada ke tak ada? Shazrin,
Ya saya.
ada ke tak ada?
Tak ada kot.
Tak ada. Tak ada sebab dia selari dengan point A. Dia mesti perpendicular distance tu, distance dia mesti 90 degrees Okay, alright. You all dah belajar Maksudnya kena 90 degrees distance. So 90 degrees distance ni berapa? Untuk W adalah 1.5. Okay. Untuk NB perpendicular distance dia yang mana? Adalah dari sini ke sini, which is berapa? 1.5 plus 2.1 adalah apa? 3.6 meter. Okay? Alright, so now we are going to take moment. So another way is for us to take moment. So we can take, you can take moment. Okay, so when you take moment, A plus, take moment equals to moment M A efektif. Sama macam ni. Ni pun dapat marks Jangan lupa buat Semua ni dapat marks. Okay. Semua dapat marks. Okay, MA equals to summation forces MA effective. Okay, now, bila kita take moment, kita boleh assume moment clockwise to be positive ataupun anti-clockwise to be positive. It doesn't matter, you get the same answer. Okay, so now let's assume anti-clockwise to be positive. Okay, so when we assume anti-clockwise to be positive, let's have a look at our diagram. Okay, so ia akan jadi what? Azim apa? Azim jugalah. Negative W
Neg-
multiply by what? 1.5.
1.5
Lepas tu
tambah dengan NB multiply by 3.6.
3.6. Okay. Lagi? You jangan tertinggal. Kita ada MA ni. Kita ada MA. MA negatif MA multiply dengan
12.
berapa? Tak, bukan 15. Sekarang ni MA kan kat sini kan. Dia punya perpendicular distance adalah ni. Which is? Ni apa?
12.
Kan?
1.2.
Sorry, 1.2. Okay? 1.2. Okay. So, you dah dapat equation tu. Daripada equation ni, you rasa you boleh dapat apa? Daripada equation ni, you boleh dapat apa? You boleh dapat NB. Betul tak? Okay. Macam mana kita nak dapat NB? So, NB equals to negative MA 1.2. Okay. Divided by negative W adalah sama dengan MG 1.5. So, berapa NB kita? So, M kita boleh potong. So, kita tinggal A. A tadi berapa? A tadi berapa? Negatif. Okay, berapa? Tolong kirakan terus. Saya kirakan. Tertinggal. Apa ni? Tertinggal apa? Sekejap, negatif MA 1.2. Oh, salah. Sorry. Sekejap Okay. Tulis balik. Saya pun silap buat equation. Okay. Tulis balik. NB 3.6 ni negatif MA 1.2 plus kan plus dengan baru divide dengan 3.6 kan. Okay. Dapat berapa NB? Hmm. Hmm. Macam mana nak potong MA ni? Hmm.
Dapat 0.659 W.
Betul? Saya punya equation ni betul? Okay. So sekarang ni kita dah dapat NB. So rasa-rasa kita boleh dapat NA tak? Macam mana kita nak dapat NA? Kita boleh pakai equation? Macam mana kita nak dapat NA? Kita boleh pakai equation yang first atas ni. Kan? So kita boleh pakai equation ni. Oops. So kita nak pakai equation ni. Kita ada, so kita NA plus dengan tadi 0.659 W minus dengan W equals to 0. So NA kita dapat, so NA berapa? Dapat negatif bawa sebelah jadi positif. So 0.341 W. So kita dah dapat NA, kita dah dapat NB. Tapi dalam sebutan W. Okay. Lepas tu kita dapat, boleh cari FA. FA dengan FB. So FA tadi kan formula dia adalah mu KN. So kita just letak our mu K yang kita cari tadi. Mu K tadi kita apa? 0.728 kali dengan NA 0.34 W. So last kita dapat FA. FA akan jadi 0.728 kali dengan 0.34. Kita akan dapat 0.2475, so 248 W. Sebab jawapan kita dalam sebutan W. Okay. So lepas dah cari FA, kita boleh cari FB jugalah. Okay, so our FB, you dapat berapa? Samalah. 0.728 kali FB tadi adalah 0.659 W. So FB 0.728 kali 0.659 dapat 0.479 lah. Okay. So ni jawapan dia, ni jawapan dia. NA dah dapat, NB dah dapat. Okay, so dah settle lah. Okay, so alright, so just nak highlight, so apa yang kita belajar hari ni adalah topik equation of motion of rigid body menggunakan Newton's second law. Okay, so bila kita menggunakan Newton's second law, kita kena consider apa tu? Kita punya free body diagram dengan kinetic diagram. Okay, cuma bezanya soalan ni yang kita buat sebelum ni, kita kena identify acceleration kita punya direction dengan value yang awal diberi tu. Okay. And then yang kedua, kita kena make sure kita punya normal force diagram pun lengkap. Now, kelas, untuk pengetahuan you all, you boleh juga take moment dekat point B dan solve the problem. You juga boleh take moment dekat point G. Okay. Kalau you nak try take moment kat point A boleh, point B boleh, point G pun boleh sebenarnya. So whatever technique you do, sebenarnya jawapan you akan dapat sama. So kalau you nak try, cuba solution yang problem yang sama, cuba you take moment at point G. Okay, kalau you take moment kat point G, you akan dapat NA, NB, FB dengan FA lah as the unknown. Okay, alright. Tapi MA taklah. Tapi sebenarnya bila you dapat soalan rigid body ni, you kena identify. There are some questions where you can take the moment at gravity point. There are some questions you need to take a moment at a different point, point A ke B ke C. But whatever you decide, it must be the easiest and simplest method for you to solve the problem lah. So today you're taking moment at point A. Maybe for a different question in the future, you cannot take moment at point A. You need to take moment at point G. So you need to try that out also. Okay. Alright. So need to try some variety type of questions. But this is the question on rigid body that uses Newton's second law lah. Okay. So that is the class for today. So any questions? Any questions? Okay. So I will stop this recording and I will share with the class.